Hey guys, it's Miss Famer. I thought today we would just do a video to refresh our memory on some ideas about probability because it's been a while and we've been getting a lot of questions about probability, and it'll help us with a lot of the examples we do in class tomorrow. So here are just some basic rules about probability. It says the sum of all probabilities in a sample space is 1, and every probability is always between 0 and 1. Some notation that you should definitely know when it comes to probability is the and this means overlap. In terms of a Venn diagram, this is where they would overlap. Of course, we have or. This is some sort of combination of events. The number of elements, so if you're ever asked about the number of elements in a set, that's that little n. It tells you the number of elements, and for example, it could be 6. Complements, you would usually see that as like A prime, something not in a set. Now, this won't come up as much in terms of complement and number of elements when we're talking about the next few probability examples, but it's still important notation that you should be familiar with. Let me just click to the next slide here. Okay, so the first thing we're going to talk about and refresh your memory on is mutually exclusive events, or they might be called disjoint. So mutually exclusive or disjoint means they cannot occur at the same time. It is not possible for them to occur at the same time. In a Venn diagram, you would see that the event A and event B cannot occur at the same time because there would be absolutely no overlap. So no overlap, nothing is shared. In terms of notation, the probability of A and B happening at the same time, if they are mutually exclusive or disjoint, it would have to be 0. It's not possible for them to occur at the same time. Here is just a little refresher on what you are given on your formula page. So you'll see combined events, that's the probability of A or B. And if you notice, there's an or here, there's an or here. That's when we are adding. The only difference is when they are mutually exclusive events, in this case, we are really just subtracting off 0, right? Because the probability of A and B is 0. So if they are just regular combined events and not mutually exclusive, you need to make sure you're subtracting off the probability of A and B. If they are mutually exclusive, you're really just subtracting off 0, so you're not subtracting anything. In terms of independent events, we see those are a little bit different. We're going to end up doing some multiplication here, and then conditional probability we will get to in a little bit. So let's just try some examples together. I think that's the best way to really refresh your memory. The first one says, find the probability of drawing either a 9 or a face card when picking one card from a standard deck. Are these mutually exclusive events? Now, are these mutually exclusive? Can you draw a 9 and a face card at the same time? No. So I can already answer that. These are mutually exclusive events. So since they are mutually exclusive, I can do the probability of A or B happening. So the probability of drawing either a 9 or a face is really the probability of drawing a 9 plus the probability of drawing a face. Now I could subtract off 0 because that's the probability that they both happen at the same time. Otherwise, I know the probability of drawing a 9 out of a deck of cards is 4 out of 52, plus the probability of drawing a face card, that's 12 out of 52. So my final answer is 16 out of 52. 2, it says in an IB school in St. Petersburg, there are 145 freshmen, 135 sophomores, 132 juniors, and 115 seniors. A student is selected at random. Find the probability the student is a freshman or a sophomore. Well, first of all, I know I'm going to need how many total students there are. So I went ahead and I added that together, and I ended up getting 527 total students. So first of all, the probability that they are a freshman or a sophomore, that's my key that I'm going to be combining events, that I'm going to be adding. So the probability of a freshman or a sophomore is the probability of a freshman plus the probability of a sophomore. Can they be both at the same time? I don't think so, so that's all I need. So the probability that they are a freshman is what, 145 out of 527? plus 135 out of 527. So my final answer is going to be 280 out of 527. The next question asks if they are mutually exclusive. Yes, they're mutually exclusive. They absolutely cannot occur at the same time. You can't be a freshman or a sophomore at the same time. Now they want the probability that a student is not a senior in part C. So that's interesting. They want the probability that they're not a senior. So what did it say? It said the probability that they are a senior would be 115 out of 527. So the probability that they're not, the probability of not being a senior would be 1 minus the probability of being a senior. So that would end up being 412. Sorry, it's so crammed here. 412 out of 527. That's the answer to part C. Good. I thought another quick refresher would be a tree diagram. I thought that might be helpful here. So it says Carl is not having much luck lately. His car will only start 80% of the time, and his motorbike will only start 60% of the time. So they asked for a tree diagram to illustrate the situation. This is still very much related to probability. So what do we have going on here? We have the situation where his car will start only 80% of the time. So he has a 0.8 chance of having his car start, and he has a 0.2 chance then of having his car not start. So these should always add to 1, 0.8 plus 0.2. All right, so once his car starts then, he has a 60% chance that what? His motorbike will start. But then that means he has a 40% chance of his motorbike not starting. Same thing here. If his car doesn't start, he has a 60% chance of his motorbike starting. And if his car doesn't start, that means he has a 40% chance of his motorbike not starting. Okay, so there's my tree diagram of my situation. So then the follow-up question for B, it says, determine the chance, so here we are with probability, that both will start. So I'm looking at his car starting and his motorbike starting. Whenever we're working a tree diagram and we're moving along branches, we multiply. So I'm going to do 0.8 times 0.6, which gives me 0.48. And then the next little part says that Carl can only use his car. So what is the chance that he can use his car? I'll circle this in green. He can use his car, but that's it. So that means his motorbike's not starting. So now I'm moving along that green branch. So that is 0.8 times 0.4, which is 0.32. Okay, next thing I want to talk about is a little bit about independence. Two events are said to be independent if the occurrence or non-occurrence of one event does not affect the probability of the other. So the probability of one does not affect the probability of the other. This is given to you on your formula page. It says if two events are independent, then you can simply multiply the probability of the first event times the probability of the second event. However, the biggest mistake we see here is that people will just do this even if they don't know that the events are independent. So make sure that if you are multiplying your probabilities, you know that your events are independent. And you can see that, where is it? Right here, independent events. All right, so let's try a little bit of this. It says, suppose you have a standard deck of playing cards. Back to the playing cards. There are 52 cards in a deck. One card is randomly selected from the deck. What's the probability of selecting a heart or a club? Well, first of all, this is review from what we were just doing before. The probability of a heart or a club is the probability of a heart plus the probability of a club minus the probability of both. But can we have both at the same time? No, so I know that's just 0. So the probability of drawing a heart is 13 out of 52. The probability of drawing a club is 13 out of 52. So the probability here is 26 out of 52. That's an easy one if you want to simplify to 1/2. All right, B says, are the events in part A mutually exclusive? Are they mutually exclusive? Yes, they're mutually exclusive. They cannot happen at the same time. You can't pull a heart that's also a club out of the deck. Part C, suppose you are selecting 2 cards now, one at a time without replacing them. What's the probability of getting a king, then getting an ace? So now we're looking at something a little different. We're looking at the probability of getting a king and getting an ace. So I can do the probability of getting a king times the probability of getting an ace. Okay, hopefully the video is still working. I cut out there for a second. All right, suppose you are selecting 2 cards now, one at a time is where we left off, without replacement. What's the probability of getting a king, then an ace? So without replacement, we have the probability of a king and the probability of an ace. Well, the probability of getting a king is 4 out of 52. Probability of then getting an ace would be a 4 out of 51. When we multiply that together, we get 16 out of 26, 52. It says, are the events of picking a king on your first card and picking an ace on your second card independent? Why or how could you tell? Well, no, they're not independent. They're not independent because the probability of the first one is impacting the probability of the second one. So let's look at E. It says, suppose you are selecting 2 cards now, one at a time, with replacement. What's the probability of getting a king, then an ace? So now we're looking at the probability of getting a king and an ace, but with replacement. This is a situation where, since we're replacing it, the probabilities are not affected. So here we go. We get 16 out of 2704. So now they're asking, are these independent? Yes. Now this time this really is working. This is going to be true, and I can use this formula. Yes, because the probability, as you can see, is not affected. All right, good. So let's move on to looking at, let's see, some conditional probability. So we're going to skip that. Conditional probability. Conditional probability is the probability of an event given some event has already occurred. I'm just going to write it over here. The probability of an event given some event has already occurred. We have some new notation for this, so it's the probability, for example, of B given A has already occurred. And the formula that you will use for this is below. The probability of, for example, A given B equals the probability of A and B over the probability of B. Let's go ahead and just do the first one together. It says, given that the probability of C is 2/3 and the probability of C and D is 2/5, find the probability of D given C. So the probability of D given C is going to be the probability of D and C over the probability of just C happening. So what's the probability of C and D happening? Well, they tell us it's 2/5. Over the probability of just C happening, they tell us it's 2/3. So it's as simple as that. You can go ahead and simplify. Also, would you want to call to your attention, the questions aren't always this basic. Sometimes they'll give you different bits of information, or you'll actually have to, in the numerator, find the probability of D and C instead of it just being given to you. There are a couple other examples here if you want to give them a try. I'll just put them on the screen, so if you want to copy them down, you can always do that and give them a try on your own. Hopefully, though, this video helps to just sort of refresh your memory a little bit about probability. A couple of things. It says if the given probabilities, just use the formula. So this is all about conditional probability. If given a table, sometimes you're given a table, you circle the column or row of what you're given, you use that as your denominator. Venn diagrams, sometimes you'll see them, and then also tree diagrams. These are just a few tips for working with conditional probability. Again, hope you found this a little bit helpful. Even if parts of it can be helpful to you while you're doing your homework and preparing for your exam, that would be good. We'll talk to you guys soon.